This video is to show how to use some given information about a trig function value at a particular angle, theta, knowing which quadrant theta is in, being able to use the double angle formulas and half angle formulas to find exact values of some other trig functions at a different angle. So here's the given problem. You're given that secant theta is the square root of 5. And immediately when I see secant theta is the square root of 5, I go, oh great, cosine theta is 1 over square root of 5. And at some point I might have to rationalize that. Right now I'm just going to use that information and say, okay, cool. Secant theta equals square root of 5, cosine theta equals 1 over square root of 5. So I've written that down, going to keep that. Let me go on. So you know that the cosine of theta is 1 over square root of 5, and you know you're between 3 pi halves and 2 pi, that theta is in the fourth quadrant. Okay, great. So cosine theta is 1 over square root of 5. You're in the fourth quadrant for theta. You're not exactly sure where, I don't know. Maybe there. Who knows? And we're trying to find the exact values of sine of 2 theta, tangent of 2 theta, and then finally cosine of theta over 2. So when I'm looking down here, I'm going to do these one at a time. When I'm looking over here to do the first one, sine of 2 theta, I'm going to use this double angle identity. So let's go ahead and get started. So I know that cosine of theta is 1 over square root of 5. I'm in the fourth quadrant. I know that sine of 2 theta, according to the double angle identity, is 2 times sine of theta times cosine of theta. I already know cosine of theta, but I need to figure out what sine of theta is, and that's great because I have sine squared theta plus cosine squared theta equals 1 from Pythagorean identity. Cosine is given to us, so really I'm just solving for sine, and 1 over root 5 times 1 over root 5 times root 5 is 5, 1 times 1 is 1, so that's a fifth. And then subtract a fifth from 5 fifths, and I get 4 fifths for sine squared. And so sine theta is either plus or minus the square root of 4 fifths. And I go back and I think about it and I say, well, wait a minute, I'm in the fourth quadrant where sines are negative. So I don't exactly know, looking at this picture here, how big, but I know it's negative. So I go, okay, great. So sine of theta is negative, and square root of 4 is 2. Square root of 5, I'm just going to leave. If I need to rationalize later, I will. But now I know both of these. So back to the original problem, using this identity, I say sine of 2 theta equals 2 times sine of theta times cosine of theta. And this is awesome because the numerator is negative 2 times positive 2 is negative 4. Square root of 5 times square root of 5, that's just 5. So I didn't need to rationalize anything. I'm kind of glad I didn't rationalize to begin with. So there's the first one. Done. The next one we're looking at is tangent of 2 theta. And so that's going to use this identity. And so I go back and I go, okay, so I know cosine, I know sine, I need tangent in order to use this identity here. So why don't I figure out, before I go much further, what the tangent of theta is? And that's going to be sine theta over cosine of theta. And so that's sine theta over cosine of theta, which is the sine of theta times the reciprocal of the cosine. And the reciprocal of cosine, that's secant. That was what we were originally given. That's great. I can simplify by dividing out that common factor, root 5. And so I get the tangent of theta is simply negative 2. Well, that's super cool. So when I go back to this identity, and I say the tangent of 2 theta is just going to be 2 times tangent theta over 1 minus tangent theta squared. 2 times negative 2 is negative 4. 1 minus negative 2 squared is positive 4. So this is negative 4 over, let's see, 1 minus 4 is negative 3. That's just positive 4/3. All right, almost done, 2/3 of the way. So now we go back to this last one, and we're going to have to use a half angle formula for this one because we're looking for cosine of theta over 2. And an interesting piece of this is that right off the bat it says plus or minus, and whether it's plus or maybe minus depends on what quadrant the terminal side of theta over 2 lies. So I have to deal with that at some point. So let me go over here and see what we've got. So we've got that cosine of theta is 1 over root 5. I know that theta is in the 4th quadrant. It's at least barely in there, and at most barely in there. It's somewhere in between, 3 pi over 2 and 2 pi. So now I'm going to think, okay, that's theta. Cut that in half, and 3 pi over 2 cut in half, or let's say multiplied by half, is 3 pi over 4. Well, where's that? 1 pi over 4, 2 pi over 4, 3 pi over 4. Here's 3 pi over 4. So if I'm an angle that's just barely past 3 pi over 2, then I'm cut it in half, and I'm just barely going to be past 3 pi over 4. Similarly, 2 pi cut in half is just pi. That's here. So if I'm just almost 2 pi, then I'm going to be almost pi when I cut in half, and anything in between is going to be in between. That tells me that pi over 2, not pi over 2, sorry, theta over 2 is in quadrant 2, where the cosine is negative. So at first it seems like, oh my God, how am I going to figure out whether it's positive or negative? It's not really too bad. I mean, yes, it takes a lot of thinking, and it takes some practice to do it, but we know that it's negative. We know that once we go through this, it's going to be negative. And so the rest of it's just plug and chug. You go, okay, cool. It's the negative square root of 1 plus cosine theta all over 2. And so now the issue is, what? Roots inside roots, complex fraction, what the heck? So I'm not going to make you simplify such a crazy thing. If I ask for exact values on something like this, I'll say, hey, that's great, move on. So you can stop this video if you like. I'm going to go ahead and simplify it so that you can see that the back of the book, or not the back of the book, that you can see the answers in the book match what you're able to get if you're interested. So here we go. So I'm going to go ahead and extract this and take it to the next page, and I'm going to double check that we're doing this right. So we've got negative square root of 1 plus 1 over root 5 over 2. And the first thing I'm going to do is I'm going to multiply top and bottom inside this radical by root 5. What that allows me, root 5 over root 5, sorry. What that allows me to do is to say, okay, so this is negative square root of root 5 plus 1 over 2 root 5. I'm going to do that again. That was really fun. I'm going to do that again. So now I've got negative root 5 times root 5 is just 5 plus root 5 over root 5 times root 5 is 5. 5 times 2 is 10. And so this isn't quite done because I have a radical in the denominator. So I'm going to go square root of 10, square root of 10. Seems like a lot of multiplying by roots, but what are you going to do? So now that's going to be, on the top, square root of 5 root 10 plus, and now let's think about this, root 5 times root 10 is root 50, which is the square root of 25 times the square root of 2. That's just 5 root 2. Alright, and downstairs I've got root 10 times root 10, which is just 10. So the very last thing you might do, maybe unnecessary, the very last thing you might do is just factor out this root 5. So I'm running out of space, but I'll factor out that root 5. And there I have root 10. In fact, yeah. Let me back up. It's factoring out the root 5, and I've still got a square root on the root 10 and the root 2. And so this isn't perfectly what it shows in the back of the book, but that's pretty close. You've done kind of the things that you mostly need to do. And so I'm going to stop there.